Good morning, I am Dr. David and Dr. Muhammad. Today, I'm going to present my project. My project title is Optimization of Indoor Air Quality for Small Commercial Office Building. When talk about indoor air quality, it's related with X-ray. From X-ray standard 62.1 say that indoor air quality is mean a majority of people exposed do not show this safety patient and authority have determined the air in will not have known contaminants at harmful concentration. However, indoor air quality is very essential issue that happen inside office building. In office building Malaysia, it provides clean, cozy, comfortable environment with good indoor air quality to ensure the employee health condition either physically or psychologically while carrying their duty inside the building. And this is because their health condition will affect the work performance and the organization performance. So IAQ is very important to maintain the employee health condition. In order to have a good indoor air quality, mechanical ventilation system is the main factor. Most of the office buildings utilized the mechanical ventilation system to maintain the good indoor air quality and also provide the fresh air by Kamaruzaman and Saprani research. The bad indoor air quality will increase the level of indoor pollutants, variable particulate matter, indoor CO2, CO concentration, thermal comfort, and relative humidity as well. And it brings health problems such as headaches, colds, fatigue, throat irritants. So the reason I'm going to do this research is because the World Health Organization had declared the COVID-19 outbreak as a pandemic on 11 March 2020, and we know that the COVID are spread through the airborne pathway and the person-to-person transmission. And as we know, as a worker, we mostly spend 90% of our time inside the indoor, like me. So it's very essential for us to have a good indoor air quality and to maintain the airflow as well. And the failure of the ventilation system also causes insufficient airflow will lead to IAQ problem. In the SARCOS research revealed the bad indoor quality causing building syndrome will affect the productivity of staff in office building and cause the economic consequences. So my project objective is to propose a system reconfiguration for improving of indoor air quality for a small commercial office space and to evaluate the effect of airflow velocity to carbon dioxide concentration, air temperature, and relative humidity, and also to compare between several HVAC system configuration for optimized acceptable indoor air quality for a small commercial office space. The scope of the study is to focus on a small commercial office space and focus on 4 parameters, which is temperature, relative humidity, air velocity, and carbon dioxide, and is conducted by the HAP and content software and focus on the HVAC reconfiguration system. In this project, I read through a several study regarding the indoor air quality. So this part is cover literature review. The indoor air quality from the United States Environmental Protection Agency said that it refer to the air quality within and around the building and structure, especially as it relates to the health and comfort of building occupants, and also concern with the temperature, cleanliness, oxygen concentration, moisture content, and movement of air as well. And they must have a lot of parameters of indoor air quality are required to determine the status, the good or bad indoor air quality. So based on the research from Katia and Carl Steck, their parameters include in their project are ventilation, level of indoor pollutants, respirable, non-respirable, variable particulate matter, indoor CO2, CO concentration, thermal comfort, and relative humidity. However, for Papadopoulos, include the temperature, relative humidity, and CO2. For Yao and Chiu and Saifullah research cover the dry bulb temperature, air humidity, airflow velocity, and carbon dioxide. And for Ponsonic and Radix cover the total bacterial count, total fungi count, temperature, relative humidity, and carbon dioxide. Besides that, they have a standard for indoor air quality. So based on the research, They have ISO 7730, which is International Organization for Standardization, and also SRES Standard 62.1, which refer to the ventilation system design and IAQ, and SRES Standard 55, which is thermal comfort environmental condition, and also DOS, which is Department of Occupation Safety and Health. And by refer to the ISO 7730 state, the temperature of the office building is between 20 until 24, and the relative humidity is between 30 to 70. And for SRES standard 62.1, the carbon dioxide requirement is 700 until 1000 ppm only. And the SRES standard for 55, for temperature is around 23.3 to 26.7, and the relative humidity around 50 to 60, and air velocity is below the 0.15. However, from the DOS, carbon dioxide is around 1000 ppm, temperature is 23 until 26, relative humidity is 40 until 70, air velocity is 0.15 to 0.50. The bad indoor air quality bring the effect of shipbuilding syndrome and the productivity problem. The Sarkos performed a study in a shipbuilding syndrome in 48 workplaces which had bad indoor air quality and found that it affected the efficiency of staff by a series of non-specific symptoms and caused the economic consequences. And the general symptom, which is headache, sneezing, odor, taste sensation, fatigue, feeling heavy headache, difficult concentrating, and mucosal symptoms, eye stroke and noise irritation and coughing, and the skin symptom on the face or hand, and they are relieved after leaving the building or room. And in the research of Bechio said that the indoor environment quality, which include indoor air quality and thermal comfort, may reduce the performance at workplace until 100% loss of productivity when employee is absent from work. So how going to measure the indoor air quality is by the survey and the physical measurement. Based on the research, the Priya and Kanya, they use the X-ray thermal scale, 7-point humidity sensation, and 7-point air movement sensation to evaluate the temperature, relative humidity, and air velocity. And Aduraman used a 5-point Likert scale to evaluate this parameter in order to measure the indoor air quality. And the physical measurement is using the several tools and instruments to collect the data and to evaluate it. In order to improve the indoor air quality for my research, I must going through some study to see what the method should be used. So from the Zender research said that he used the decentralized vacuum ventilation system, which can improve the indoor air quality by reduce the carbon dioxide concentration by adjusting the supply and exhaust setting. And the Alitros and Cartic, they only apply for natural ventilation, which can reduce energy consumption, whereby can improve the indoor air quality by applying the opening window only. In this study, it includes the computer modeling and simulation. So based on the research, they have a hourly analysis program which can calculate the design cooling and heating load for space and zoom, and also determine the required airflow rate for space, zoom, and system, and also can determine the CO2 level. And another software is a Tang, which can simulate the airflow and pressure, such as room-to-room airflow, and also the contaminant concentration and personal exposure to the contaminants. And it's supported by the research as well, and from the Emmerich say they use for the multi-zone building airflow and contaminant transport simulation. In chapter 3, I'm going to present the methodology. So for the process 1, which is data collection, is about to collect the data of the indoor air quality based on the survey and the physical measurement. And the result was compared to X-ray 55 standard and the X-ray 62.1. And the process 2 is acquisition of building condition, which is the design parameter of physical office were developed using the AAP software with the existing component configuration of HVAC system. And also the survey regarding the indoor air quality assessment were discussed. The process 3 is the comparison of existing building condition, which means a comparison between the measured data and the design data to determine the indoor air quality problem. And for the process 4 is to propose a HVAC reconfiguration system, which is the The proposed methods were similar in 5 office rooms to improve the indoor air quality, and the proposed methods are natural ventilation and decentralized ventilation. And the natural ventilation, it was simulated by using constant airflow with open window, and decentralized ventilation was simulated by using constant supply fan with different exhaust airflow. And both simulations are used to simulate the indoor air quality parameter in an occupied small commercial building, which are operating temperature, relative humidity, airflow velocity, and carbon dioxide. So for process 5, a result analysis, the comparison between two HVAC system configuration in each room were discussed to optimize the acceptable indoor air quality, and analysis the effect of the airflow to carbon dioxide concentration and air temperature and the relative humidity as well. And if the indoor air quality is achieved, the modeling was ended. So the instrument for measurement included, which is the Laska data logger used to measure the temperature and humidity. However, the model digital HVAC analyzer used to measure the air velocity, and the M702, the sensor used to measure the carbon dioxide. And this is my flowchart of my study. It will start from that one data collection, after that acquisition, then the comparison of existing building, then propose a HVAC system reconfiguration. Then after that, we'll do the result analysis. Last, we'll achieve the indoor air quality. So the parameter include is temperature, relative humidity, air velocity, and carbon dioxide, and include the HFV software and content as well. So this is a reference that I refer through the different journal, and this is my Gantt chart, and I'm going to continue my research on the next semester and continue to data collection and analysis as well, and to simulate the two different methods and to get the to improve the indoor air quality. So this is my presentation for today. Thank you.